And we are live with our 127th episode of Absolute AppSec. I'm Ken Johnson at CK Tricky on Twitter, joined by my lovely co-host, Seth Law at Seth Law on Twitter. Seth, say hi.
Hey, everybody. Welcome back to another episode. I know we're just launching into it. There's all sorts of stuff going around from a news perspective in the last few weeks. Life has been really busy. It feels like everyone's getting back into more normal type stuff, right? But other than that, we don't have any announcements, I guess, is what it boils down to. So we're just going to jump straight into a couple of topics this week, specifically ones that are coming from the top 10 web hacking techniques of 2020. Let me post that up there really quick. Whoops, that's the wrong one.
I do have actually one announcement.
Okay.
I am hiring for 2 positions at GitHub that are both bounty support related. And so I'm going to find that link and post it here shortly. But did want to let folks know that we are hiring for those 2 positions. And yeah, if you want to know more, you can hit me up in Slack. But the job description covers a little bit. But basically, it's first level triage of bounty submissions and interacting with bounty researchers and helping manage our VIP program and all this stuff. So there's a lot to it, but it's all bug bounty related. So if you are interested, I will post that link. And so that's all I had. I just had to, I had to do it.
Yep. Ken needs help, everyone. Yeah. I mean, if you've never done that before, it's a good introduction to security topics and actually doing research into why bugs occur. I had an interesting one pop up. I mean, as a consultant, I help a couple of smaller companies run their bug bounty programs. And we get some really bizarre esoteric bugs that pop in there, like Regex Flaws. This one was specifically, and I know this wasn't on our topic list, but it was interesting, so we may as well talk about it, right? Basically, this one was Rails related, Ken, which is interesting, right? There's like a config.host parameter in, I can't remember. It's like for host authorization, right? That builds a dynamic regex. Anyway, the problem is that the way that they had built their regex, a slash at the very end actually allowed it to match any domain as opposed to not having a slash at the end, right? Like issues like that pop up with regexes and actually having to dig into what's going on with Rails and how it's implementing or pulling those strings to create the regexes was a very interesting just kind of research topic after the fact. And I don't have my notes here about it, but at the same point, it was an interesting deep dive into how Rails handles things, how regexes work, right? All that kind of stuff. And, the bug bounty positions will give you that background if you haven't had them before. So it's super interesting. Along those lines, I know a couple of weeks ago, we talked about job descriptions for junior positions, right, Ken? That was Daniel had asked about it on Twitter. We talked about it a little bit. I mean, it sounds like this is more of a junior position. Is that correct?
Yeah, it's fairly we are looking for more entry level folks to sort of help them build their skill sets with some web security knowledge, obviously some basic security stuff. One thing I wanted to mention too, since we were talking about, first of all, we need to circle back to that Rails bit because this is the first I'm hearing about it. So I actually don't. I haven't even heard about what we're talking about. So we'll go back to that. But one thing you reminded me was that from last week or the week before, I said I would post that the race condition odd bug, the details would be posted of why GitHub reset everyone's sessions. And that I just posted the link to. It is a really good read. It dives into just how extremely weird and buggy, or not buggy, but weird and infrequent, and how hard that was of a bug to for them to track down. So just a little follow up. But okay, so going back to the Rails bit, sorry, where did you hear about this? When did this come out?
No.
What
Okay,
was the?
Okay. Rewind. This was a small bug bounty. It was basically the way that this company had built the regex, or they were loading configuration parameter into like its host authorization, right? It determines where you can redirect things to, right?
Right.
So it's used in that logic. So a bug bounty researcher found that if you put a slash at the end of the parameter and the X forwarded for header, it would actually redirect to any place that you wanted it to. So the location regex that was being built basically had a flaw because of the way that they were building out their configuration file, and then it was being consumed by the host authorization, middleware in Rails. Like, it was just a super kind of esoteric edge case. If you would have looked at the regex, you would have been like, oh, it looks fine, right? Like if you looked at their configuration file. But the fact that you combined a domain with a special character, the slash in this case, just completely meant it matched anything and it worked, right? So it was just kind of one of those I'm constantly learning when you're dealing with those bug bounty researchers and with the stuff that comes in, because it is a lot of those edge cases that we don't get. I mean, we might have tracked it down in the source code review and we're looking at the configuration settings, right? But I don't know if we would have, to be honest with you, right? Now it'll be on my list. Oh, I know this is handled by regexes. How are those regexes being built? And right, it's one of those things we should be looking at, but I don't know if I would have caught it, to be honest, right? During a source code review. So.
Yeah, my AirPods had cut out when you were saying where that came from. That's why I was like, wait, what happened now?
It wasn't a widespread Rails thing. It was just a one-off. Yeah.
Well, one common mistake people make with Ruby is that, typically with regex, you've got the caret sign and the dollar sign, and that delineates like start and finish, and there's nothing more to it. But one common thing that kind of bites Rubyists who are trying to implement regex the same way they would in another language is that you actually have to use those \A and \Z. Here, I'll just type it. I'll just put it in those characters, because these delineate those are the actual anchors, regex anchors, basically in Ruby. Let me write that. Regex anchors in Ruby. Yeah. Sorry. Anyways.
And honestly, that's a problem that I have coming from more of a Perl Python background. Is I write regexes like Perl RE, right, or Python RE. Right. Those regex libraries are very similar. So dollar, caret, all those different things, right? When I first started looking at how this regex was implemented, I saw those two characters and I was like, what the hell's going on here, right? Like, those damn Rubyists, right? Always have to be special. That's yeah.
Well, yeah, I mean, what's interesting is I found bugs before, and one of my favorite bugs of all time was because there was no anchor, I was able to, and there was like I've talked about this before and, showed examples, maybe even in Railscope, but the gist was that they were not using proper anchors. And so a new line character could sneak in there. And I think, I remember what this was. Yeah. So with active record, if you do like a .find and you pass in a value, it immediately gets cast to an integer. So what was happening was we were doing ID lookups. They were parsing two parts. The first is the ID and the second part is a hash. And as long as the hash made sense, the first part of that, hyphen separated value would be the ID. And then you do the find on it. But what was happening was that, going back in my memory bank, so when you do a .find and you pass it a value, it gets converted to an integer. So if I gave it, say, like number 3 \n for a carriage return and another ID value, so 3 \n, I don't know, 500, right? Well, it would immediately say, I don't forget what the behavior is. It's going to dump the part that's after the new line, essentially, right? So the 500 part goes out. So let's say the original lookup was supposed to be for let me make sure that's actually right. I think that's I think that's right. But what would happen is it would just cut it off, right? So I was able to slip in, because there were no anchor tags, a new line and a different ID. And then what was happening was the hash would be like, okay, because they did these in separate places, they would have a check somewhere that was like, the hash is good, move on to the next check. The next check would then use that ID that's like real ID, the ID I want, new line, different ID. And it would just cut off the new line / different ID, and then just return the record for somebody else, basically. So that's one example of like a bad regex check and what can happen when you don't use anchors. But the final thought here for me, Seth, is use this. If you are a Rubyist trying to figure out regex, use that.
Yeah. And actually, it's funny that you popped that up, because that was kind of the first place I turned when I was like, wait, how the hell is this actually succeeding, right? Like, I just loaded the regex in there and started throwing stuff at it. So
Rubular is my favorite. And my Rubular is my favorite for validating other people's regex or writing my own.
Yep. Cool. Well, good resource. So anyway, that's the kind of stuff you learn when you're doing bug bounties, right? So it's a good way to expand your knowledge, even when you're a seasoned professional. So, all right. So there's a couple of these web hacking techniques of 2020 from Portswigger that I wanted to talk through today. We'll see if we get to both of them, because they're pretty interesting, and it actually has a lot to do with the regexes that we're talking about, right? Like evading. One of them's the WAF evasion. I think that might be the first one in the list, but I don't know. That's number 10. Sorry. The one that I wanted to talk about first, though, was number 3 in that list, which is attacking secondary contexts in web applications. And I'm running into this more and more. I know we wanted to talk about kind of the code side of things, Ken, and we'll address that here momentarily. But there's a great presentation by Sam Curry. Let me post that in as well.
I actually just posted it.
Oh, you did? Okay.
Yeah,
great.
I'm putting it in Slack now.
Yeah, there's a great presentation by Sam Curry on these secondary contexts. And this all goes back to how web servers and web application servers are now used in conjunction to serve up a web application, right? So you think about a typical path for a web app. It's like mydomain.com/myapp, right? And then you serve up files like index.html or, index dashboard or whatever based on myapp/something else. Now, what Sam Curry goes through is the interactions between the different components can be taken advantage of. So if you've got like a PDF lookup that takes a part of that path in the application and then goes to a secondary, so similar to what would be a server-side request forgery attack, right? But in normal behavior, it would go out and pull a resource from somewhere else and return it. You may be able to take advantage of what URL is being sent, or even what just path is being sent, to figure out other resources that might be available from that secondary context or that secondary web service behind the initial application that you're dealing with. And I don't know if I'm describing that super well, Ken, right? Like, what's your take on those secondary contexts?
I think you're describing it well. And maybe we should share out the presentation. Well, here, one thing I wanted to point out is, I'll just share this real quick. So this is what's interesting. You and I were talking about this before we went live, which is what's interesting about this presentation. It's very similar to like the routing portion of our course. But like, this is the dynamic side, what you see as a bug bounty person or as a pen tester, potentially not having access to source code. So for us, all of this is like known, but it's interesting to see it from the perspective of somebody who is just learning about this dynamically. So what's interesting here is, for instance, they talk about, here's how I thought HTTP servers worked, where there's a file in a specific folder, you have got a web server running, and anything you request is going to be basically pulled out of that folder, and it's going to be rendered. Well, obviously
that is. Yeah.
That is the way that used to be. Go ahead.
Yeah, that's what I was just going to say. And Yeah, it's the way it used to be. This is the base functionality for web servers. So Apache, anything else, you specify a directory, tie it to a domain or a port where it's looking it up, and all it's going to do is go render those files and send them across. Right? But yeah.
I'm just agreeing.
Yeah. But nowadays, with things like Node, Flask, Rails, right, we do routing, which is a completely different concept. So instead of depending on the web server to handle that for us, we're now letting the application and the code itself dynamically determine what should be returned to a user. And that's what we were looking at here, different ways web applications do routing. I think he's looking at a node here where he's, and again, like there's regexes that are involved here, right? Let me see.
Sorry, I didn't mean to switch.
No, you're fine.
Yeah,
there's regexes route. So there's like this main user router.route, and then it has activate, which actually gets turned into a regex behind the scene. So it parses the HTTP requests. It looks and sees, oh, okay, that starts with activate. If it's a get, I'm going to return this one page. If it's a post, I'm going to do something else, right? And the application itself determines what the routing looks like and what's returned to the user. It's no longer the web server that's handling it, just looking in a folder. It's now the code itself. And that's where these flaws start to pop up.
Well, one thing we've shown specifically in Node is there's let me back up before we get into that. Yeah. Well, actually, no, I'll talk about this and then I'll back up. So, because you mentioned regex, and like one thing we show in the course is that there are so many ways that even in just routing, like for those that aren't familiar, we break it down when we talk about the flow of a web app into assessing routes, authorization. This is just at a high level. Routes, then authorization filters, then controllers and actions. Whether or not it's called a controller action in that framework, that's logically how we actually call it like the logic processing, which would be your controller and actions. And then your data, and then your data retrieval, which is like your model and your ORM level. And we talk about tertiary systems like external logging and like maybe S3 or Azure services or something like that. So, that's sort of the general flow though. And we show where vulnerabilities are present. And in routing, and because of what Seth said, to add to what Seth said, because of the complexity in routing now and the options that are available, vulnerabilities absolutely get presented inside of just the route definitions themselves. And it manifests differently. And one thing you should always do when you're assessing some framework you're not super familiar with, or even if it's just maybe a later, newer version than what you've assessed previously, is you should always go back to the documentation and look at their routing documentation. So like here, one thing that you'll see with, and maybe I can pull it up real quick, but one thing you'll see with like Express, for instance, and its routing is that you can actually pass in regex in the routing parameters themselves. So you can basically say if a route matches these. So like, for instance, if I wanted everything under the admin directory to hit a certain authorization filter first, I could do that. I could say with regex, if it hits anything admin, then like do this or do this authorization check. But that's actually where things go wrong. So just real quick, this is an example of how wonky it can get. So like you start to see there's look ahead regex checks. There's, just like asterisk for anything type deal. Like, so anything in between A, B, and C, D. There's all kinds of ways to do this. So you can essentially use regex, like I said, on a path and say anything that goes there is going to hit an authorization check. Now, why is that interesting? Because people fail at regex all the time. So those authorization checks, I've seen this happen. We talk about it in the course. I've seen this in my job where the regex wasn't done properly and literally no authorization checks happened on administrative functionality.
Yeah.
So sorry, that's a long-winded, but yeah, that's interesting, I think.
Yeah, but this is exactly what the article is going back to, right? is those sorts of secondary contexts underneath or behind the scenes. So, what happens when you put, %2f in there, when you start using URL encoded characters after /admin, in the case of Express specifically, where it's building a regex, it sees /admin, or maybe, there's like just a, /index, and you get a %2f in there and a ... /admin, maybe you can bypass the authorization check that's on the admin endpoint, and then it's not on the dashboard or not on the index point, right? These are exactly the sorts of flaws that we're starting to look for, right? And so we always talk about kind of the, how do I always phrase it? Right now, I can't even remember. My brain's all over the place today. But the pattern, like anti-pattern analysis, right? So there's a pattern
code smells.
Yeah,
but from like a security perspective.
Yeah, you're looking for the pattern that doesn't exist when it should exist there, right? So in admin or somewhere else, like you should always be doing an authorization check and making sure that things are flowing properly, right? Like, but what Sam's doing and what he's enumerating through and attacking those secondary contexts is exactly the sorts of issues that we want to be looking for in the code. And we are looking for them, but we've always just called it a different thing, right? We have the tendency to rename the same vulnerabilities over and over in the industry. And the longer you're involved, the more you'll realize that. So
the latest hotness is the thing that was still a thing a long time. Anyways, so one interesting thing I was going to mention though too is how we there's certain times when this is a good time to bring it up. There's certain times when it's like, no, source code alone review is not enough. This is actually one of those times, I think, because one of the things he shows in the example here or in his slides, multiple things that are shown inside the slides are a chain. So, for instance, one of the screenshots shows, and again, maybe I should share my screen here. One of the screenshots shows requesting like a favicon icon. And it basically shows what is clearly an S3 authorization issue. So they're directly requesting a resource on the domain of the site. And for whatever reason, it coughed up an S3 error. Maybe they sent some garbage data in. I don't honestly remember. You're welcome to pull that up if you want, or I can pull it up. But yeah, actually, here it is. I'll share that real quick here. Yeah, so.
Well, and I think the point that you're getting at here is that, Mike, we don't there's always, there's multiple
layers. Right, yeah. That's what I'm trying to get at, exactly. You see the backslash, or sorry, the / there, the %2f. That's I'm assuming that's what caused the hiccup, was that it was like, adding in that additional parameter in the routing. But like that's the point, is to summarize this all, you've got your route that the application has defined behavior. You've got in front of it potentially a proxy load balancer that is determined, based off of the path and the information you gave in your HTTP request, is going to determine where that route goes to. So that's one layer. Then you've got the second layer being the server, and the third layer, or actually, sorry, the second layer being the case where your CDN potentially is just knows, like, because you can tell your CDN which routes are supposed to go off to, like, say S3. So you've got that. So you've got your load balancer and proxy, you've got your CDN, and then you've got your actual application doing routing. So in that case, in what is not an overly complicated app, you've got 3 different places. Then if you talk about, routing based off of path to various microservices, it gets completely more bananas, but yeah.
Yep. Yeah. I mean, you start throwing Kubernetes and microservices into that mix as well. And the route that like Nginx handlers that are passing stuff based on what's available, it gets super complicated. And like, I look at this example and you can definitely see where it's happening, right? Like from our perspective, like we understand that the CDN is doing something. We understand what those components are because you and I have seen these errors before, right? Like I know you have, I know I have when we're testing things, and not necessarily in a case where like Sam's taking advantage of here. But yeah, it's just like it all gives an attacker more information. And that's the interesting thing that Sam is stepping through in the presentation is he's gathering more and more information about what's going on. I know he didn't specifically call it out, but it looks like he did get paid from Yahoo on some of this, right? Verizon Media, right? And we know the guys that are over there running that program, their bug bounty program is huge, right? But it's super interesting, right? Like the way that you can take advantage of these systems as they're interacting, or the interaction between these systems, because they are going to get confused as far as what they're supposed to do with these different URLs. Yeah, it's all super interesting, right? The 2F here, and it all goes back to kind of this input validation and only accepting what we know to be true. Don't trust the user, right? Like I have all these little sayings that I use when I'm teaching. But the interesting thing here is who's at fault, right? Who screwed up? Because I don't feel like there was one person that coded something incorrectly. It was just it's kind of a cascading effect.
Oh, absolutely. And I mean, it's all the regular stuff that you would expect. Like, so it's chaining together IDOR with shows SSRF and XSS and CRLF, which if you're not familiar with line feeds, you can manipulate essentially headers. You could even in some cases have like two separate responses, the original response the application wanted, and then since you've injected a new line, you can have an entirely different response that you want that might actually execute your cross-site scripting attack. And perhaps the first one was done correctly and wouldn't. And they talk about, here different passing in different parameters that paths and parameters that will then be like potentially either routed somewhere differently, or after it's met the bar for that authorization check on that route, perhaps it didn't meet another bar. So you're slipping in additional information like, a different location for a file to be retrieved. And so on that second check, the second part of where that logic lives, it's just doing a lookup on that additional data and then bypassing the original routing definitions authorization controls. And these are the types of things we see all the time. This is so common. And it's just cool to see somebody like take all of the different incantations, put it into a kind of a summarized way, and then show at the end how they retrieve both payment information and profile information, I want to say, or billing information or something. I have to go to the bottom. So that's billing stuff. There was before that though.
Payment.
Something else. Yeah, so there's PDFs. Right. So invoices, but that's not payment details, right? So it has emails and invoice numbers. That's great, but not necessarily payment information until they determined. And this is actually something I wanted to talk about too. Man, I thought I wasn't going to have much to talk about, but dude, like actually there's a lot to cover here. So like, for instance, they found out that this is kind of the format, right, for the subscriptions. But like what I thought was interesting about this is that we've seen this before where there's this weird separation of authorization. So there'll be like an authorization check that says, is this ID they're providing valid? And there'll be a second check that'll say, if that's valid, then use the guessable, knowable, enumerable value as the way to actually retrieve the data. And this is like, yes,
this happens all the time. Yeah.
So anyways, that's just, I just think there's so much to unpack there. I'll stop sharing so you can share, because I assume it's easier if you're controlling your slides as you share and talk about it. But yeah.
No, I mean, I think I don't know if there's much else that I wanted to share on that one. Let me see. Again, I just found it like it's incredibly timely because these are the sorts of vulnerabilities. Like authorization and authentication are hard problems, right? And the more complex your application, the more difficult it becomes. And if you're not writing some sort of huge authorization checker and a bunch of unit tests around it, it's more than likely that you're gonna have problems, right? So yeah, like exactly what you're speaking to. I like recently was doing a code review and a pen test and found an instance where within the same organization you could actually like edit someone else's page, even though you shouldn't have permissions to do that, just by changing an ID parameter that was being sent in. And it's that same sort of a check that the developers are more worried about, functionality and then returning the correct data. And then they forget that there's these edge cases that we're dealing with, these secondary contexts where, hey, guess what? Person A maybe shouldn't be able to see person B's data, right? There's got to be additional checks in there. And so the initial, is that person logged in or are they a part of this group, doesn't necessarily cover all of the edge cases that are applicable to authorization for a specific site, for a specific resource.
It's also easy for a developer who is maybe either newer to the team that they're working on or newer to the application that they're working on to not know all of the various actor types and the various authentication methods that they use to access their data, and not be able to account for all of the places in the code that you have to account for that, unless it's well documented and someone has like peer reviewed, sure, but paired with them on adding, like, say, an API route. And you think, well, it's pretty simple, right? Like a user A, user B, user C. But maybe there's a little bit more difficulty if like they're as a part of a different group. Maybe you split it into different organizations, different groups. But in reality, something like take GitHub, for instance, you're talking about personal access tokens, you're talking about user to server tokens, you're talking about GitHub apps, and they have server to server tokens and user to server tokens. OAuth apps have their user to server tokens and their actual server to server tokens. You've got your actual regular users coming in session based. You've got internal API calls, right? That other services are calling. And then when you start to take into account the cognitive load of all those different actor types, you like start to realize, oh my God, like there's so many places in this code that I have to account for these things. And if you're not, again, if you haven't documented it super, super well, or if someone just hasn't taken the time to read that, or just didn't know the documentation existed, or didn't paired with someone, or didn't have a peer review, like it's easy for these things to slip in over time. So, yeah. Well,
I mean, and honestly, right? Like it seems like there's been a lot of scrutiny on GitHub Actions recently, right? I don't know if you want to talk about that, but I mean, realistically, it's because it's a new feature, right? Like I know you guys, relatively new, but it seems like there's that Teddy Katz or whatever that's been releasing a couple of different things, and I'm sure you're dealing with it at some level. So,
no, man, totally easy going over here, and nothing going on.
Because 5 days ago that was the GitHub Actions or the secrets, right? Like stealing arbitrary
GitHub
secrets.
Actions has been a target since even before it was released GA. It's been a big, because you're spinning up you're spinning up computing power on someone else's behalf through the platform they push code to. You're doing a lot of that in like a lot of it's right, it's just automated. So and of course there's like secrets that have to be stored, and of course there's things that it needs to connect to and services it needs to talk to. So it's like, yeah, and also we've talked about it before, but yeah, there is the vanilla way of doing it, which is probably the safest, which is using GitHub's compute infrastructure. But there's also self-hosted runners where you can plug into your own action infrastructure and run it out of GitHub. And so that's a whole other ball of wax, right? Where the guarantees are less, because the guarantees, the guarantees are all on you and your organization. So Actions has been of course, a big target, and I feel like I know that Codespaces will too when that's gone GA as well. That's going to be for all you bug bounty researchers. I'm sure you're chomping at the bits for that one. So I'll probably be the person you end up interfacing with, or at least in the back end. If you don't know it's me, that's who's probably handling that stuff. But anyways, yeah, man, like it's Actions is tough. It's very tough.
Yeah, I didn't know if you wanted to talk through that, right? Like, we can take that offline, and then I'll bring it up next week, maybe. So,
yeah, well, I actually need to do more homework because we've had a few things go on. So, like, I need to brush up before we
have the discussion. Yeah,
before I say the wrong thing and people face palm.
Yeah, so. One of the things was that when I was reading through one of the blog posts, that he eventually was able to get some secrets out of GitHub Actions, right? And I think it was some of that hosted infrastructure, if I remember right. But one of the interesting things was him just sniffing around Actions looking for random bugs, right? Finding things that, hey, maybe it's not a security issue, but it's really interesting to figure out how developers have put things together based on the behavior of an application and kind of where those edge cases sit. And I know you and I talk about this all the time, is 90% of our research, like when we're doing code review, maybe even more than that, ends up in not a vulnerability, right? Or it doesn't end up in us actually being able to write anything up about the application. But there's strange edge cases that are out there. And that's where the code smell comes into play. Is you get to know an application code base and you start looking at code, or you start looking at a framework and you're like, wow, that feels weird, right?
Right.
And that's where most of my good bugs come from, is that, wow, this feels strange. I don't think this is right. Places. So
yeah, anyway, and you know, when I'm going through the review, as you know, because since we talk about this pretty extensively, I write it up as usually if I'm doing the source to sync trace that we talk about, I'll write it up there and then come back to it. And sometimes like it seems like it's just a code smell. And then sometimes you circle back and you know, and we talk about circling back, always circle back. You go back through your notes and you say, well, and what about this and this? And you start to chain those together. And then you feel like, oh, wait, that's not just defense in depth anymore. This isn't just a code smell. It's an actual bone. But even if it isn't something that's actively exploitable, to your point, I always write that up and I always mention it and always classify it as a, you know, fix this as a defense in depth layered approach. Because if something else, like, and I think the most prevalent, easy, common example is when people do something like create a method that if it's called directly, which it would, there's no comments on it, that's put in a place that you could definitely think that I should call this method directly. But if you do call it directly, you're completely without authorization, any checks whatsoever. And yeah, you've just put a method in that right now might be called by something that has the authorization check, but it could be easily called by something that doesn't. And that's like one of the very vanilla common examples. But the things we've seen this on, I know for me, it's super varied. I know for you, it's super varied. It can be like fairly more complex than that. So,
yeah. Yep. Yeah. Cool. Yeah, I'm trying to think if there's anything else to put a bow on that discussion, but yeah.
One thing right? I do want to mention, man, is that if anybody's listening and hasn't gotten swag before, now is that time of the episode where I say send an email in the next like half hour to absoluteabsec@gmail.com. Again, that's absoluteabsec@gmail.com. Send an email with your t-shirt size, preferred t-shirt size. I don't think I have many magic times left. That's kind of a limited edition one. But yeah, send it with your address and your t-shirt size, and we will get that mailed out to you.
Sweet. So. Okay. Send it across. All right. Well, then let's jump over to, it's number 10. In the top 10 web hacking techniques. And like, I don't know if we've done a full breakdown on the top 10. I know we mentioned it. Actually, a couple of those are very, very specific to technologies like, Image Magic or, Mobile Iron. So it's interesting and it's kind of cool, but it's not as widespread as something like the secondary context, where we can kind of use those techniques across different applications, which is partly why I wanted to highlight these couple that I pulled out today, because we run into secondary context all the time, just like we're saying, and the same thing here. These WAF evasion techniques, right? These have been around for a long time, right? Since WAFs exist. And WAFs are web application firewalls, if you're not familiar with them. But let me go ahead.
I'm pasting the link in for you.
Okay.
Yeah, don't worry about it. I'm slow.
Nope, you're fine, right? The interesting thing here is he does step through kind of the typical WAF detections that are out there, and then starting to mess with the WAF parser. And this goes back again to regexes that we deal with. Apparently that's the theme of the episode. I didn't realize it when we were putting together all this, but the way that he goes about figuring out where those edge cases are to bypass a WAF is pretty interesting, right? It's not the standard. It is taking advantage of kind of obfuscation and the chunking techniques, right? Is that what? Hold on, I'm scanning through it right now.
Yeah, like the double content length headers, but basically, I mean, if I had to summarize, it's like, don't send your entire cross-site scripting payloads. Like try to send them in incremental, like parts of it, like the greater than, less than, or to mess with headers like it shows, like where you're doing double content length. So it doesn't know the WAF doesn't know which content length header to process. Just basically kind of doing funky stuff with the headers and putting in just very minor amounts of potential HTML impacting characters and elements. They show SVG. They show trying like onload with SVG, which SVG is one of the more, I feel like SVG is one I've seen a lot of actual successful XSS attacks through, just because of the fact that it has metadata inside of the SVG that can be, you can put your XSS payload inside the SVG, and usually people don't think too much about, well, again, sandboxing and CSP are like two major ways to prevent all of this anyways. But if you wanted to like do actual, I'm not going to say whitelist, blacklist. I actually prefer allow list, deny list. And by the way, that's like a super stupid thing for me to maybe even bring up in terms of like this whole article. It's not stupid, but trivial. But just so people know, like I actually like the allow list and blacklist, or allow list and deny list, because it helps me cognitively understand that better. It makes more sense than like, and I know there's like other like PC reasons and all that stuff, but for me, it's just easier to remember than whitelist, blacklist. And I wish we would go to that. I wish we had gone to that from the beginning, because it's just easier to remember. But
yeah, it is like it doesn't make it doesn't make a lot of sense, outside of the issues that exists with that sort of language, right? So
right. Messing up with
I was just going to say SVGs, right? And Derek's bringing this up as well, as SVGs. I mean the way that SVGs are built is it does do some sort of data processing with XML. It's an XML format, right?
Right.
Which does make it an easier target than some of the other binary formats that are out there, right? It is easy to embed something in like some of the GIF, flags and other things that are out there. But SVG seems to have a lot of parameters that you can play with to execute an XSS payload. But again, so back to those WAF evasion techniques, right? The chunked encoding was the one thing that was fairly impressive, right? So using the transfer chunk to actually break up your payload so that it wouldn't trigger those WAF rules to actually put, because the WAF doesn't necessarily put that back together when it gets the chunked payload. That's what it was that I was thinking about. It doesn't put those back together before it processes whether or not it should accept that request, right? Or pass it on. And so they're
looking
using
at it in pieces, not the whole.
Yeah, exactly. And we do that in there's multiple different attacks that do that, right? This is kind of, the WAF evasion, but we have seen this in the past for like IDS evasion or IPS evasion techniques, right? Which is, just on a network level, right? Splitting up your TCP packets so that you're sending data across multiple TCP packets with enough time difference that doesn't get, put back together by the IDS and can get executed behind the scenes. So again, like we're kind of reinventing these techniques for the new technologies that we're dealing with. And that's where I was going with that. So
Derek mentions that if it's an image tag for the SVG, the script piece does not execute. And if otherwise, if it's embedded, or, that's that I knew. I don't think I really remembered that, or I'm trying to like validate that because he says that's the case, and I didn't know.
Yeah. I mean, he's right. The image tag prevents that script portion from being ignored. Or
it makes sense.
Sorry, I said that wrong. I did a double negative, right? The script portion does not get executed if it's inside an image tag. I do remember that from trying to do XSS inside of SVG.
Yeah, my memory sucks, so I didn't. I'm sure I've come into that so trying to.
If you load it directly, right? If you load it directly into the browser, then it will execute those script portions, right? But inside of an image tag, it will not.
It makes sense. It makes sense that there's no reason that you would want the image tag to do that. I mean, I would imagine anyways.
Yeah. The other thing that I find really interesting, and this goes back to the different technology that we're using, like the double content link that you were talking about, Ken.
Yeah.
To actually inject or take advantage of, hey, the WAF only sees the first content length, and the browser, or not the browser, but the server behind the scenes actually executes the second one. We've seen this sort of a technique used multiple times, whether it's header injection as it's coming back to the browser, and the browser may be like getting confused on which content type it should be executing. Or in this case, it's the content length that they're confusing the WAF, they're confusing the backend web server that's behind the WAF with a secondary header. And part of this can be solved if those technologies are implemented per like HTTP RFC, right? I think in the RFC spec, it actually says that the second header of the same type is the one that actually is valid for that request or that response, right? Or that HTTP payload. But that's not always the case. The developers don't always look at the RFC when they're putting together those technologies, right? Or they're depending on, maybe the WAF is just using Apache, and Apache does it one way and Nginx does it another way. Or maybe it strips it out as it's passing it through, right? Like the proxy headers. Like I'm not sure exactly on how the technology is all going to exist, but then that does go back to the secondary context, the way that regexes are handled, right? Like it's all a big mess, is basically what I'm trying to say. And until you test it, you just don't know.
Yeah. Which is again a good reason to remember that both source code analysis and dynamic testing are equally important. I mean, I think that, which is probably weird for us to say since we talk so much about source code review and we do the training, but I do think it's like a mistake when people only do source code review. I think there's a lot of value in source code review. I think you can get through. You and I know that there's a lot you can get through pretty quickly with source code review. So just from an efficiency standpoint, but also like for a deep understanding of the application and being able to chain together things and see that in the code, that's great and fine. But unless you test things dynamically, you're also there's also going to be bits like WAFs, and there's going to be proxies, and there's going to be load balancers, and there's going to be CDNs. There's going to be factors that change, that alter the behavior of the application, and you can't see that when you're just looking at the code alone.
Yeah. Yep. So. Yeah. I mean, there's advantages to isolating code and isolating components, looking at them by themselves. I don't know, right? Like it all goes back to the fact that we're just glorified QA testers. I'm going to be honest, right? Because like we do this, like, a source code review as a developer, we write a unit test around that. That unit test goes into play, but then a QA tester actually does integration testing where they're trying to put the code into the environment where it's going to live and then test all the edge cases there, which is what we do as dynamic penetration testers, or, a web application penetration test, whatever you want to call it. That is that technique, right? It's the same thing that a QA tester is doing, but they just have better requirements written out when they get to that point. We are obviously, like from these articles, we're discovering this on the fly.
Right.
There's not a user story that's written around, hey, you shouldn't be able to put in a %2f in a URL and access other resources, right? It should just strip that out. Had that user story been written and handed to the QA team, guess what? It probably wouldn't be an issue. But yeah, we aren't writing those sorts of security user stories in general, right? Like I don't see a lot of organizations doing that. Anyway.
Well, I got to get going soon, so I did want to mention a couple things. One is that next week I am out, so we will return, I suppose, on April, I believe it's 6th, I think, with Stefan. We have 2 guests beyond Stefan in April, so April is going to be a pretty more guest-heavy month for the podcast than previously, since somebody got off his lazy ass and started scheduling people. This guy. But yeah, so next week we'll be out again. If you somebody wants swag, email. Oh, sweet, I got it. We got some emails for swag. So good, you folks who emailed up will get your swag. Anything else, Seth, that you can think of that we need to cover before we hop off?
No, I don't think so. I know you're out next week. I may try to put together just a short video to push out maybe on some secure code review stuff, just kind of an overview. We do want to start producing some more kind of formal training videos or just short snippets on secure code review techniques. So watch for that. If I can get some time, I'll put something together, and maybe
it's just going to be you with a glass of whiskey in front of a fireplace, like, come gather round, tell stories of yore.
It's like Ron Swanson's Yuletide video where he just sits there for an hour drinking whiskey. Sounds like a great idea. But we'll see. If I can get that out, I will. If somebody prods me along, I'll talk with Justin, and we'll get something figured out. Probably just be like a 5 or 10 minute kind of intro, and where we want to take things. But otherwise, we'll see everybody in a couple of weeks. Please join the Slack channel. We'll keep the conversation going there. Good discussion today. So thanks again for being involved and for listening.
Thanks, everyone.
Ciao.